Project Thor, the metal that could redraw the world map. There is a moment in every great shift of global power when the ground literally moves. Not metaphorically, not diplomatically, literally. When something buried beneath the earth is pulled into the light, and the people who understand what that discovery means go very quiet for a moment and then begin making phone calls. That moment happened in Saskatchewan, Canada, in January of 2026. And most people who watched the news that week had no idea they were witnessing the opening move of one of the most consequential resource stories of the 21st century. A discovery was announced. A name was given to it, Project Thor. And the world has not yet fully understood what that name will come to mean. Canadian Energy Metals Corporation, a private mining company led by CEO Christopher Hopkins, stood before cameras in Saskatoon, Saskatchewan, and announced the results of a preliminary economic assessment of what they are calling the Thor Project. Located near the small farming town of Tisdale in east-central Saskatchewan, the deposit contains an estimated 49.5 billion tons of ore, and within that ore, 6.8 billion tons of alumina. That number is not a typo, 6.8 billion tons. According to Hopkins, that figure represents approximately 1/3 of the entire world's known supply of alumina. In one deposit, in one province, in one country, alumina is the chemical compound from which aluminum is produced. Aluminum is not simply a material, it is the skeleton of the modern industrial economy. It is in every aircraft flying overhead. It is in electric vehicles. It is in batteries, in power transmission lines, in smartphones, in aerospace and defense systems, in the packaging of nearly everything modern civilization produces and consumes. When Hopkins said that anything that moves products, transmits power, or stores energy uses aluminum, he was not exaggerating. He was describing the circulatory system of the global economy. The deposit sits just 50 feet below the surface of the ground, extraordinarily shallow by mining standards, which dramatically reduces the cost and complexity of extraction. Existing rail infrastructure runs directly through the area. The project is located at the geographic center of North America. And the preliminary economic model projects a net present value of $72.3 billion, an internal rate of return of 72%, and a mine life of 25 years, producing 1.8 million tons of alumina annually. Saskatchewan Premier Scott Moe stood beside Hopkins and said he believes the Thor project will prove as important to Saskatchewan and to Canada as potash and uranium. Two materials that already define the province's economic identity on the world stage. He was not speaking casually. He was drawing a straight line between what Saskatchewan already is and what it is about to become. To understand why this discovery lands with the weight it does, you have to understand the existing architecture of the global aluminum supply chain, because that architecture is broken, and everyone who depends on it knows it. Today, most of the world's aluminum supply originates in China. China dominates bauxite refining, alumina production, and aluminum smelting with a grip that rivals its control over rare earth elements. China produces roughly 57% of the world's aluminum. The rest of the supply chain is fragmented across Australia, Guinea, Brazil, and a handful of other producers, none of whom can be described as fully reliable from a geopolitical standpoint. Guinea, which holds the world's largest known bauxite reserves, has experienced political coups. Australia is a reliable partner, but geographically distant. Brazil faces its own structural instabilities. Canada currently produces around 3.3 million tons of aluminum per year, roughly 3 to 4% of global consumption. Almost all of it is smelted in Quebec using hydroelectric power, which makes Canadian aluminum among the greenest produced anywhere on Earth. But Canada has always had to import its alumina feedstock, the essential raw material, from other countries, primarily Australia and Guinea. That dependency has been a quiet structural weakness in an otherwise strong production story. The Thor project changes that equation entirely. For the first time in its history, Canada would have a domestic source of alumina on a scale sufficient not merely to supply its own smelters, but to supply a significant share of global demand. Hopkins described the alumina in the Thor deposit as extractable from polymetallic shale formations, a completely different geological origin from conventional bauxite. The extraction process is designed around low-carbon principles and produces what Hopkins called the greenest aluminum on Earth, produced using Canadian hydroelectric power from a domestic alumina source. There is another dimension to this story that most coverage has missed entirely. The deposit also contains meaningful concentrations of scandium and vanadium. Scandium is a critical element used in aerospace aluminum alloys, solid oxide fuel cells, and advanced materials manufacturing. Vanadium is essential in vanadium redox flow batteries, one of the most promising large-scale energy storage technologies for grid-level renewable energy. The Thor project is not just an aluminum story, it is a critical mineral story. And critical minerals, in the geopolitical vocabulary of 2026, are the new oil. Now layer this discovery on top of the existing trade confrontation between Canada and the United States. The Trump administration has imposed 25% tariffs on Canadian aluminum exports, threatening to deepen that pressure further. The stated rationale has been to protect American domestic production. The effect has been to raise costs for American manufacturers who rely on Canadian aluminum as a feedstock. At the precise moment when the United States is applying maximum economic pressure on Canada's existing aluminum industry, Canada announces the discovery of a reserve that could make it one of the dominant players in the global aluminum supply chain for the next generation. The timing is not coincidental in its significance. It is historic in its consequence. Follow the resources, the money, and the power because they are flowing in very clear directions. Canada wins enormously from this discovery if it is developed with strategic intelligence. The Thor project, fully developed, would transform Canada from a mid-tier aluminum producer dependent on imported feedstock into a global anchor of the aluminum supply chain. It would give Canada leverage it does not currently possess in negotiations with the United States, with European buyers, with Asian industrial consumers, and with any nation that depends on aluminum for its manufacturing base. It would generate tens of thousands of direct and indirect jobs in a province that is already among Canada's most mining-capable jurisdictions. And it would position Canada as the geopolitically reliable alternative to Chinese aluminum supply that the rest of the Western world has been quietly desperate to find. Saskatchewan specifically benefits from a structural economic transformation. Premier Moe has spoken of the discovery in the same breath as potash and uranium. And those two commodities have made Saskatchewan one of the wealthiest provinces per capita in Canada. If aluminum alumina achieves even a fraction of that status, it reshapes the province's fiscal trajectory for decades. Global manufacturers benefit, particularly in the aerospace, defense, and electric vehicle sectors. Every major automaker, every aircraft manufacturer, every battery producer in Europe, Japan, South Korea, and the United States is currently navigating extreme supply chain anxiety around aluminum and critical materials. A reliable, geopolitically stable, green North American source of alumina is exactly what every procurement team in those industries has been searching for. The demand is not hypothetical, it is structural and urgent. China loses strategic leverage. The Chinese dominance of the aluminum supply chain has been one of Beijing's most quietly powerful tools in trade and diplomatic negotiations. When you supply 57% of a material that the entire global economy requires, you have influence that extends far beyond formal diplomacy. A major new Western source of alumina, especially one paired with Canadian hydroelectric smelting capacity, begins to erode that leverage, not overnight, not completely. But the direction changes. American manufacturers who depend on aluminum lose in the short term if tariffs on Canadian aluminum products persist, because those tariffs raise their input costs without creating domestic substitutes. But American manufacturers also benefit enormously if the Thor project accelerates the development of a secure North American aluminum supply chain. Because a Canadian alumina source feeding Canadian smelters, Feeding American factories is exactly the kind of supply chain security that American industrial policy claims to want. There is a deep irony in the fact that the administration imposing tariffs on Canadian aluminum is doing so at the precise moment when Canada is developing the resource base that could make North American aluminum self-sufficient. The left hand is penalizing exactly what the right hand should be celebrating. The investors who identified this opportunity early, and Canadian Energy Metals has been developing this discovery since the initial drill in May 2022, stand to benefit from one of the most significant resource discoveries in recent Canadian history. A preliminary economic model projecting a $72.3 billion net present value at a 10% discount rate is not a small number. It is the kind of number that moves institutional capital. History is full of moments when resource discoveries rewrote the terms of global power, and the patterns they follow are remarkably consistent. The discovery of oil in Saudi Arabia in 1938 transformed a peripheral desert kingdom into a pivot point of global geopolitics. Within 2 generations, the ability to supply or withhold a single commodity had made Saudi Arabia one of the most diplomatically significant nations on earth, regardless of its military strength, its population size, or its democratic credentials. The resource was the power was the resource. The discovery of lithium reserves in Chile and Bolivia produced a similar dynamic in the 21st century, as the world's appetite for electric vehicle batteries suddenly made the Atacama Desert geopolitically relevant to every major industrial nation. Countries that had been largely peripheral to global finance and diplomacy found themselves at the center of supply chain conversations in Tokyo, Berlin, Washington, and Beijing. Canada's own history of resource discovery offers a closer parallel. The development of the Athabasca oil sands in Alberta transformed Canada's energy profile and gave it leverage, particularly with the United States, that it had not previously possessed. Saskatchewan's potash reserves gave the province and the country a form of agricultural supply chain power that made Canada an essential partner for food importing nations across Asia and the Middle East. Each of these moments followed the same basic pattern: discovery, skepticism, slow realization of scale, geopolitical recalibration. The world does not immediately understand what a discovery means. It takes time for the consequences to propagate through supply chains, investment flows, diplomatic calculations, and strategic planning cycles. We are currently at the very beginning of that propagation for Project Thor. There is also a parallel in the industrial history of Germany's Ruhr Valley, the coal and steel heartland that powered the German Industrial Revolution and made Germany a dominant industrial power by the late 19th century. The Ruhr's significance was not simply in what it produced, it was in where it was located. This located at the center of a continent, connected by rivers and roads to every major European industrial center. Saskatchewan's geographic position, at the center of North America, with existing rail infrastructure connecting to every major market on the continent, carries echoes of that same structural advantage. Aluminum markets are already pricing in the anxiety of the existing supply chain. U.S. aluminum premiums reached record highs in the wake of tariff announcements, a signal that the market is fully aware of how concentrated and fragile the current supply structure is. The Thor project's announcement has not yet fully registered in global commodity markets because it is still in the preliminary assessment stage. But as the project advances toward pre-feasibility and then toward development, its weight on aluminum pricing and supply forecasts will grow. For the broader critical minerals market, the Thor project signals something important: that the Western world's search for alternatives to Chinese supply chains is beginning to yield real geological results. That signal matters to investors, to policymakers, and to the industrial companies that have been making long-term sourcing decisions under conditions of extreme uncertainty. The clean energy transition amplifies everything. Aluminum demand is projected to grow substantially over the next 2 decades, driven by the electrification of transportation, the expansion of renewable energy infrastructure, and the increasing use of lightweight materials in everything from wind turbines to satellite systems. Every electric vehicle requires more aluminum than the internal combustion vehicle it replaces. Every utility-scale solar installation uses aluminum framing. Every high-voltage transmission line upgrading the aging electrical grid uses aluminum conductors. The demand trajectory is not speculative. It is engineered into the transition itself. The vanadium and scandium dimensions of the Thor deposit add layers of market significance that the initial coverage largely overlooked. Scandium is currently produced primarily in Russia and China, and its supply is so constrained that it has limited the commercial deployment of scandium aluminum alloys despite their superior performance characteristics. A significant North American scandium source would unlock industrial applications that have been economically out of reach. Vanadium flow batteries are one of the leading candidates for grid-scale energy storage. The missing piece that would allow solar and wind power to provide reliable baseload electricity. A major Canadian vanadium source arrives at exactly the moment when the energy storage industry needs it most. The investor, who has spent a lifetime thinking in decades rather than quarters, would look at this convergence: a massive resource, a perfect geographic location, a green production process, a surging demand curve, and a geopolitical environment that makes supply security worth paying a premium for. And ask his favorite question: and then what? And the answer, played out across the next 25 years, looks like a transformation of Canada's position in the global industrial economy. Consider the plausible futures with clear eyes and a long horizon. In the first scenario, the one that requires patience and strategic discipline, Canada develops the Thor project deliberately, with an eye toward maximizing not just resource extraction, but industrial value creation. Rather than simply exporting raw alumina, Canada builds processing and smelting capacity within its borders. It captures the value-added steps of the aluminum production chain rather than shipping the raw material to be processed elsewhere. It builds an aluminum industrial cluster in Saskatchewan, smelters, fabricators, manufacturers, that creates tens of thousands of high-quality jobs and embeds aluminum processing into the Canadian economic identity for generations. In this scenario, Project Thor becomes for Saskatchewan what the Ruhr Valley became for Germany, a foundation of durable industrial power. In the second scenario, Canada develops the resource efficiently, but primarily as an export commodity, shipping alumina to existing smelters in Europe, Asia, and elsewhere. This is faster and requires less capital investment, and it still generates enormous economic returns. But it captures less of the total value chain and creates fewer long-term industrial multiplier effects. It is the path of least resistance, and it is the path that resource-rich countries have most often taken and most often regretted. In the third scenario, the most strategically significant one, the Thor project becomes the cornerstone of a North American critical minerals partnership that resolves, or at least reframes, the current trade confrontation between Canada and the United States. An administration that is genuinely interested in supply chain security rather than merely in leverage would recognize that a Canadian alumina deposit of this scale is a strategic asset for the entire North American industrial base. Joint development frameworks, preferential offtake agreements, and coordinated investment could turn a trade confrontation into an industrial alliance. Whether the current political environment allows for that kind of strategic thinking remains to be seen. What is certain is that the world just learned something about Saskatchewan that it did not know before January 2026. And the world, when it learns things of this magnitude, does not unlearn them. Capital will flow toward this discovery. Industrial strategists will factor it into their planning. Governments will engage with it diplomatically. The project is in its early stages: preliminary assessments, demonstration plants, pre-feasibility studies. But the direction is set, the size is confirmed, the infrastructure is already there, and the demand is growing every single day. There is a quality that separates the great long-term investors and strategists from everyone else. And it is not intelligence. It is not access to information. Most people have access to the same information. The quality that separates them is the willingness to think in decades when everyone else is thinking in days. To ask not what this means right now, but what this means in 20 years. To follow the resource to its logical destination rather than stopping at the headline. Project Thor is a headline today, but it is a structural reality for the next quarter century. The aluminum that will frame the electric vehicles of 2040 may well come from the ground beneath Tisdale, Saskatchewan. The aircraft that will carry the next generation across oceans may be built from metal that began its journey 50 feet below a Canadian wheat field. The batteries that will store the energy of the sun and the wind across entire grids may contain vanadium extracted from the same polymetallic shale that Christopher Hopkins first drilled into in May of 2022. Power in the 21st century is not primarily military. It is not primarily financial, though finance is the mechanism by which it moves. It is primarily material. Whoever controls the materials that the global economy cannot function without controls the terms on which the global economy operates. For most of recorded industrial history, that control has been fragmented, contested, and unstable. Whoever discovered it first and moved fastest held the advantage until someone else found a new deposit or a new technology or a new supply route.